All right, let's go ahead and talk about some of the vocabulary words that we will be using in Unit 5 and specifically in this first lesson. So we're going to be talking about systems of equations, solutions, no solution, infinite solutions, perpendicular, intersection, coefficient, parallel, slope, and ordered pair. So let's go over a few of those. When we say coefficient, we're talking about the number that's in front of a variable. So for instance, if I had, if I had 3x, let me get on my pen, my coefficient would be 3, okay? And sometimes we call that a leading coefficient. So the big thing that's new in this unit that we're going to focus on is systems of equations. So this is going to be a set of 2 or more equations with the same variables. So we're talking x and y. Sometimes you might, like in a application problem, you might have like G or J for jars, but they have the same variables. So what we're trying to do with systems of equations is find a solution. That's normally what they're wanting us to do, is find the solution. So the ordered pair where a system of equations intersects is our solution. Okay, so when they ask you for a solution, it's normally going to be written as an ordered pair, like x comma y. And it must be true for both equations. So when you plug in x for x in your equation and y for y, they both have to be true statements. So we'll do some example problems coming up in this unit, but there is always a way to check your answer, which is really great. We can also solve systems of equations by graphing. So when we graph a system, it can have one solution, that would be right here, no solutions, or infinitely many. So when we graph something, if they are intersecting lines, meaning they cross at one point, it's going to have one solution. Okay, and remember, these are straight lines. So it's only going to intersect one time. If they are parallel lines means they have the same slope. That means they're never going to cross. So if they never cross, then we're never going to have a solution. So that would be no solution. And then sometimes we have the same line graphed on top of itself. So that's technically 2 lines there. And in that case, every single point on the line is a solution. So that's where we would have infinitely many solutions. All right, and then just a real quick review, slope is going to be the rate of change of an equation. So if you're counting it on a graph, it's going to be rise over run. And if you're using 2 points to calculate it, you're going to have y2 minus y1 divided by x2 minus x1. Oops, that's x. All right, and then lastly, just a reminder that an ordered pair, when you list an ordered pair, it's x first, then y. All right, so let's go over some of these systems. So you know by now how to graph a linear equation. So a linear equation, it actually has the word line in it, and that's a straight line. So when we graph a linear equation, we are first going to find the y-intercept. So if y is by itself, which it is over here, the constant or the number without a variable at the end, sometimes it can be flipped around, it could be at the beginning, but it's the number without the variable. That's our y-intercept. So in this case, our y-intercept is positive 4. So I would come over on my graph and I would put a point at positive 4. And then what I'm going to use it next to find my next point is the slope. So this is negative 4/5. So I can either let the negative be on the top and go down 4 to the right 5, or I can switch it and go up 4 and to the left 5. So we're going to go ahead and just let this be negative 4/5 for our slope. So that means I'm going to start at my y-intercept and I'm going to go down 4. 1, 2, 3, 4. And then on the bottom, this is a positive 5. So I'm going to go to the right 1, 2, 3, 4, 5. And I'll put a point here. So as you can already see, A is not the answer. So I'm looking for a line that looks like this. Okay, so it's not A. We can tell it's not C. It's not B. So D it is. And you would just check that it has a y-intercept of 4 and then count your slope. Okay, so that's just a quick review of graphing linear equations. Because today our goal is to graph and solve systems of equations. So we're finding solutions to a system of equations. So what are systems of equations? Well, it is 2 or more equations that have the same variable, and that will create a system of equations. For example, we have x and x, y and y. So that is a system of equations. So what is the solution to a system? A solution is the point of intersection. So one way to solve a solution or solve a system of equations is to graph. Okay. So why is a solution to a system of equations only one point? Well, if we think about it, we're graphing linear equations, which means they are straight lines. So in order for me to have 2 lines that intersect, they're only going to intersect one time. If they intersected again, they would curve or be like a quadratic. So there's only one point or one solution because they are linear equations. It would not be possible to have more than one solution unless, like we talked about going over our vocab, unless the lines were graphed on top of each other. So if they were the same line, then they would have infinitely many solutions. Okay, so what we're going to do here is go ahead and solve a system by graphing. So I'm going to draw myself a coordinate plane. And this one, we're really lucky because it is already in slope-intercept form, sorry. So we don't even have to get y by itself, which is awesome. So we're going to go ahead and start graphing. I am going to graph the top line in red and the bottom line in blue. So the top line has a y-intercept of -10. So I'm going to come down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and put my y-intercept right here. My slope is 2. Okay, so that's like 2 over 1. So I'm going to go up 2 into the right 1, up 2 into the right 1, and go ahead and draw my line. Hopefully yours is straighter than mine. So that's how I graphed the first one. The second one, I'm going to go ahead and go up 1, 2, 3, 4, 5, put my point here. And this is a slope of -3 over 1. Oops, that's a 3. So I'm going to go down 1, 2, 3 to the right 1. I might have to extend my graph. 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. So you can see that that is where it's finally going to cross. So we are looking to write the ordered pair for this point. So that would be x comma y. So my x value is right here at 3. And my y value is at 1, 2, 3, 4. Was it 4? -4? Okay, so I had mentioned earlier that there was always a way to check your answer. So if we're not exactly sure if this is correct, what we can do is take our original equations. So I'll do this one in red because I'm going to do the top equation. And instead of y, I'm going to plug in what I said my y was. So it's -4 equals 2 times 3 minus 10. So now I just use basic algebra. 2 times 3 is 6. 6 minus 10 is -4. So I have to make sure that this is a true statement. Does -4 equal -4? Yes. Now, the key with systems is that we have to make sure it's true for both equations. So I'm going to go ahead and use that same solution, -4 for y, and check on the bottom. So -4 equals -3 times 3 is -9. -9 plus 5 is -4. So does -4 equal -4? Yes. So then that means my solution of 3, -4 is the solution to this specific system of equations. All right, so let's try to graph another one. I'm going to graph the top one in red. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, put a point. And my slope is -2/1. So I'm going to go down 2 and to the right 1. And for these, you'll want to kind of continue on for a little bit. Since we know we're looking for a point of intersection, we want to make sure that we have enough points on a line. All right, and then I'm going to graph this bottom one. So my y-intercept is at -2. And in this one, I'm going to go up 1 and over 4. And as you can see, I will have already 1, 2, 3, 4 found my point of intersection. So when it asks me for my solution, it's going to be this point right here, which is going to be 1, 2, 3, 4 for x and -1. And again, I can plug in 4 for y and I can plug in -1 for y and 4 for x and make sure that I get my answer. So 2 times 4, or -2 times 4 is -8. -8 plus 7 is -1. So -1 equals -1. And over here, I would get -1 equals 1/4 times 4 minus 2. 1/4 times 4 is just 1. So 1 minus 2. And again, we get -1 equals -1. So that means our solution was correct. Okay. So what if they aren't in slope-intercept form? Well, we have to get them in slope-intercept form. So what we would be doing then is solving for y. Okay, so this is just a quick little review. Again, we want y by itself. So what I'm actually going to do, since this is a -8y, I'm going to add 8y to both sides. And I would get 11x equals 8y minus 48. I'm going to add 48 to both sides. And then divide everything by 8. So my final answer then would be y equals, we have 11 over 8x, and then plus 6. So if you get two systems of equations that are not in y-intercept form, what you will need to do is just put them in y-intercept form, and then you'll graph them. All right, so we talked about how to check to see our solutions. Now, let's say that you are given two lines, so a system of linear equations, and when you go to graph them, they are parallel lines. So right now, we know that they appear to be parallel. We can know for sure that they're parallel if they have the same slope. So what we're going to do is take this first linear equation and solve it for y. So what I'm going to do is add x to both sides. So I had -x plus 3y equals 6. I'm going to add x to both sides. So I would get 3y equals x plus 6. Divide by 3, divide by 3, divide by 3. Y equals 1/3 x plus 2. So my slope for this first one is 1/3. Let's check and make sure that the slope is the exact same for this one down here. So I have 3x minus 9y equals 9. I'm going to go ahead and add 9y to the other side so I can get rid of that negative. So I get 3x equals 9y plus 9. I'm going to subtract 9 from both sides. 3x minus 9 equals 9y. And now I'm going to divide everything by 9. So 3/9 simplifies to 1/3. So 1/3 x minus 1 equals y. And again, I have the same slope. So because I have the same slope for the top and bottom equation, that means my solution is going to be that there is no solution. These are parallel lines, and parallel means we're never going to intersect. So this would be a no solution. Okay, so here's kind of that work if you want to see it written out or with some words on there for you. Okay, so let's look at this one. We have a graph here of x equals 3y minus 1. So let's go ahead and solve that one for y. So x equals 3y minus 1. I'm going to add 1 to both sides. X plus 1 equals 3y divided by 3, divided by 3, divided by 3. Okay, this one's a little bit difficult to graph. So 1/3 x plus 1/3 equals y. So my y-intercept is going to be kind of at 1/3 here. Okay, I would go up 1 over 3. All right, so there's that line. Okay, when I do this over here, if I go ahead and solve for y over here, if I add 6y to both sides, I get 2x equals 6y minus 2. So I add 2. I'm going to keep it going over here. So I get 2x plus 2 equals 6y. I'm going to divide everything by 6. And again, 2/6 simplifies to 1/3. So I get 1/3 x plus 1/3 equals y. That is the exact same line. So since our system is 2 of the same line, that means every single point on this line is a solution. So therefore, this would have infinitely many solutions. Here's that work shown again. Okay, so this is just a little bit of a review. There are 3 possible outcomes when you are graphing systems of solutions. You're either going to get 2 lines that intersect at one point. So therefore, there's one solution. You will have parallel lines that do not intersect. So therefore, there is not a solution. Or you can have what we call coincident, meaning they're the same line, they're inside each other. And in that case, we would have an infinite number of solutions. Okay. Here it is again. Okay, so how will it look on the star? You might get a question like this. Which of the following graphs best represents a system of equations that has no solution? So no solution means we're looking for parallel lines. So we want lines that do not intersect. So we know B is not it. As you can see, C, they're getting closer together, so they're going to intersect. And what we want to do to be 100% sure is count our slope. So you can kind of tell that A is not exactly parallel. They're getting closer together up here. Okay, so that's one way that you might see it on the star. Another way you might see it is use the graph method to solve the systems of equations. So they're going to give you 2 equations and ask you to graph. And the point where they intersect is going to be your solution. So in this case, remember we write our solutions as x comma y. So our y value is 3 and our x value is 0. C would be our answer. Another way you could check this is by taking each of these x's and y's and plugging them into both of your problems down here and seeing if you get a true statement. Okay, I want to do another one with you that is a table. If you get a table of values, if you see the same ordered pair up here, so this would be your X and your Y, if it has the same point, that means that they intersect. So therefore, it would have one solution. And that is all that I have for you for this lesson.